properties of real numbers, right? That's what it says. The first part of this is review, right? What are real numbers? What does it say there?
All rationals and irrationals.
All rational and irrational numbers, right? What is a rational number?
All numbers that can be represented in the form n over n, where n and n are integers and n is not equal to 0.
You know what that means?
No.
Anything that can be expressed as a fraction where the denominator cannot be 0, because that doesn't exist, right? Yes. So it can be expressed as a fraction, can it?
Yeah, so what is
So
that?
that's part of rational numbers, right? Yes?
Yeah.
Okay. What's an irrational number?
All non-terminating.
Non-repeating decimals.
All non-terminating, non-repeating decimals. What's an example of an irrational number?
9.884.
Sorry, say it again.
9.84.
You're not speaking math. Say it again.
9 and 84.
9 and 8400. Good. Way to go. Good. We have to learn how to speak math. And I'm only calling you out because you said it. I'd like to speak math. Yes.
1/8.
1/8. Okay. So those are rational numbers. Give me an example of an irrational number. What's a number that has a decimal that doesn't repeat and goes on forever?
Pi.
Pi, the most famous of them all, right?
4, 3 divided.
Repeating. Repeating. Thirds are repeating. Okay? So that's rational. The other examples are square roots that aren't perfect squares. The square root of 2 is irrational. Square root of 3, etc. Okay? Square root of 27 is actually irrational. Good? We're okay with that, right?
Yes.
Got it? It's 3 root 3, by the way. Got it? Sutherland was in thinking mode. No?
Now it's not-
You were in La La Land? All right, great. So now we have the idea of irrational numbers. Let's talk about the next one. What's next? Integers, right? What are integers?
Like a number does.
What are integers?
-3, -2, -1, 0, 1.
All negative and positive numbers.
Negative and positive, what type of number? Whole number. Positive and negative whole numbers. You with me, Sienna? Boring, right? You've seen this a million times. Yes, ask away.
So they should get rid of rational numbers.
Why?
I mean, no, natural numbers.
Natural numbers. Why? Why?
Because it's just one difference, the 0.
One simple difference, and that's great. And we're going to talk about that momentarily. Congratulations. That's next, right? We have wholes first. What are whole numbers?
0 on.
We call them the counting numbers, right? Counting numbers that start with 0, right? And then the natural numbers. You've learned this before, that's why I'm going so fast. Natural numbers are, that start with 1 and go up, right? All the positive whole numbers starting with 1. Come in.
It was in the thing on the shelf, like in the barber shop. It was on the window. I saw it.
Yeah. I give us homework so
I don't have that water bottle. Stoltenberg has it. He has it. He thinks my water.
No, that was this one.
Thank you.
That was Hadaway's.
That was this one. That's not from
Whatever. Bye. We're working and recording. Great. Now you know. Let's look at those examples. Now, let's just go ahead and name the sets of numbers that each of these guys belong to. Number 1, 6/7. 6/7 is irrational?
Yeah.
No, it's rational. Can it be expressed as a fraction?
Yeah.
Is the denominator 0?
Oh,
No,
Then it's rational, right?
is it repeating?
Yeah. I mean, it's repeating, but it's not non-terminating.
So it just goes on.
It has a set of numbers that repeat. I think 4 digits repeat, I believe. If I'm not mistaken. I don't know off the top of my
I
head.
didn't know if they repeat or not, that's
They do repeat.
the only hard part to tell.
The way to tell if it's non-terminating and non-repeating is if it's not a perfect square but a square root, or pi, or Euler's number. Okay? If it's listed like this as a fraction, you can pretty much guarantee that it should either repeat and or terminate. Okay? It has an end before it repeats. Good? So, what else does it belong to?
what?
What else does 6/7 belong to?
Natural.
Numbers,
It is not a natural number.
it's a real number.
It is a real number, is it not?
Yes.
Does it belong to any other subset?
6.
No. That's it, we're done. Okay? So let's look at the next one. The next one is -√81. We have to do some work here, right?
Oh,
Negative
so
9.
that's just integer.
It is an integer. Why isn't it? You just said it, right?
What? Negative 9.
-9. So we keep the negative because it's outside. Inside it would be a complex number or imaginary number. Outside we just keep the negative. Now we have -9. What's -9? It's an integer, right? So it's a z, we know for sure. It is it rational?
You know, it's irrational.
Can we,
Yeah,
why would it be irrational?
Because it doesn't have any non-repeating decimals.
So if it's irrational, it's non-terminating and non-repeating
it's
decimals.
an integer, it's rational.
Rational means it can be expressed as a fraction. Can you express this as a fraction?
Yeah.
So it's rational. Is it a whole number? Is it a natural number?
No.
No, because it's negative. And the last thing, is it a real number?
Yeah.
Is -9 a real number?
Yeah.
You bet. Why do we learn this? Because when you get to pre-calc, you start with this. But we have to remind you, right? Let's look at number 3. Number 3 is 0. Wow, fits into a lot, doesn't it?
Whole number.
WCI.
Wouldn't
Is it
negative,
irrational?
so wouldn't -9?
Is it irrational? It has a non-terminating, non-repeating decimal? Really?
No.
0 has a that number right there.
It's a whole-
I've written out a decimal and it just keeps going.
No, it doesn't have a repeating. No, it does.
It doesn't have any decimals.
Zero.
It's a whole number.
It is a whole number.
Well, if it's a-
Is it a natural number?
No.
but is it-
No.
if it's
So
a-
most specific is it's a whole number. Is it an integer?
Yes.
Yeah.
It's listed right there, isn't it?
Yeah.
Yes.
Can I list it as 0/1? Why not?
You can't.
What's 0 divided by 1?
You can't divide 0.
No, that's not true. You can't divide by 0. Right?
Yeah.
So 0/1? Great. 1 over 0? No way. Doesn't exist. Have you ever asked Siri what 0 divided by 0?
Yeah, she talks about the Cookie Monster.
Cookie Monster? Can't divide by 0.
Undefined.
Only God, only an omnipotent being can divide by 0. Turn something into nothing parts. Right? Go for it.
I'm bored.
Sit. You can't divide by 0.
I can't.
Dude, you can't divide by 0. Don't. I have 2 exits in this room. Feel free, off you go. You'll have to take this class online. Okay? Any other interesting ones on here?
It's a O.
Where?
0.
0.
Oh. Oh, wait, I thought it was irrational.
Why would it be irrational? You're getting mad at irrational numbers.
I thought that anything, like, a natural number is every single one of those numbers. I thought it was like the bottom one and above.
So, no. Natural numbers start at 1 and go upward.
You know what I'm saying? A natural number is also a whole number, which is also an integer, which I thought was also irrational.
Right, but 0 is not a natural number.
Well, yeah, I'm not saying that. I'm just saying, for example,
Well,
like,
why are we there?
I don't know.
Why are we there? Yes, 73, natural, right? Right? It's everything except irrational.
So irrational is just a separate one.
Yeah. Here, let's look at irrational. We don't have irrational yet. 17 is irrational. Right?
Yes.
How? What's the square root of 5? It's irrational. But it's being expressed as a fraction. We have a non-terminating, non-repeating decimal that's being divided by 2. So non-repeating, non-terminating,
It's not terminating.
it doesn't ever end. Like pi.
So why would it-
And they have supercomputers right now that are trying to figure the final digit of pi. They've been going since the 70s. And they've found billions of digits of
Sure.
pi.
So when it's finished, will you be happy when it gets like solved?
But it'll never end.
But what if it won't?
Well, then we'd have to say it's
Does pi even make sense? Like, how does it work? How do they get? Where do they get those numbers from? Like, do they just grab it from the thing?
Is it like some?
It's the relationship between the circumference and the diameter
Oh.
of the circle.
Yeah,
Oh.
it's so.
Every circle.
You ever saw the simulation of how pi looks like? It's like the spiral which never meets the other end. It just keeps
Makes
going,
sense.
going, going.
Makes sense. Ever inward? Ever inward?
What?
It goes ever inward,
Yeah.
right? Never meets itself, or else it would terminate. Good? All right, I think you have a handle on this.
Or if you could use pi to power.
Do you have a handle on this? Kind of have a handle on this, right? To a certain extent. Getting that idea of irrational is annoying, because we don't see it a lot.
Energy.
Like when we start playing with radicals later and simplifying radicals, they will almost all be irrational because they'll have some form of root 3, root 5, root 7, root 11 when we simplify. Whether there's some coefficient in front of the radical or not. That backside, this, because root 5 is irrational, this whole thing has to be irrational. Because isn't this the same as that? Aren't those two things exactly the same? They are. Isn't dividing by 2 the same as multiplying by a half?
Yeah.
Okay. Cool. I'm nervous, are you? Okay. Here we go. Turn it over.
Wouldn't 0 be a real number too?
Yeah, I didn't write it. Thanks, dude.
Yeah, that's what I thought.
Thanks, dude. Eagle eye bonus. Oh, no. Did you turn it over? What do you see?
Simplifying expressions.
Okay, what do you see at the top in the big boxes?
Properties of real numbers.
Properties of real numbers. Oh, rats.
Oh, I
Remember these?
No.
No?
Yes.
Really.
Isn't there a lot?
What's the commutative property?
A plus B equals B plus A.
Boring. What does it mean?
Same thing on both sides. You can, add or multiply.
In
Any order.
any order. You can add or multiply in any order, and you'll still get the same sum or product, right? You'll still get the same answer. So 3 plus 1 is the same thing as 1 plus 3. That's perfectly logical. Does that make sense? -6 plus 8 is the same thing as 8 plus -6. Do you agree?
Yes, sir.
Well, what if this were multiplication?
Then would it be?
That's perfectly fine.
Same thing.
Same thing. Yes. Commutative. Change the order. If you need to fix that in your notebook or fix that on there to say we're talking about order, do it.
So, isn't there
Yes.
a lot more? So I remember when I was doing this, I feel like there was just a lot more of just that commutative associative than the inverse closure. I felt like there was a lot more. I feel
Not that we need right now.
Yeah, not that we need right now.
There are other properties, yeah. Okay. What's next? The associative property. What is the associative property? What do you see?
A plus B in parentheses and then plus C.
Okay.
Then A plus parentheses B.
Is 7 plus -2 plus -5 the same as 7 plus -2 plus -5?
Yeah.
Is that the same?
Yes.
Yeah, doesn't matter, right? So it's associated to commutative property, but we're looking at what's in here. As long as these guys are all addition, we're great. Is it the same with multiplication?
No.
No. No, you don't see any multiplication there, do you?
Unless it's all multiplication. All positive.
Ah, if all the values are positive, sure. But look what happens. Look what happens. Parentheses and a value outside just means multiply anyway, right? I don't have, I'd be redundant if I put in a multiplication symbol here. Well, now, is -14 times 5 the same as 7 times,
Isn't that -5, sir?
where?
14 times -5
14 times -5 is the same as 7 times 10?
Four times. Yeah, you can. Wait, no, it's the same. Same.
So if everything stays the same, it'll work out. But what do I bother you with? Addition.
You just can't put, addition is addition.
Yeah.
Can't change stuff.
Same thing, right? Even if they're all negative, same thing. Yeah. Now we have associative. Just flip it around. What's the identity property? What does it look like?
A plus 0 equals A equals 0 plus A.
So it means if you add 0 to anything,
So
it
it's
stays the same. Shows its identity. Can't divide by 0. There you go. What do you multiply by to show that same value?
0.
What's the identity property with multiplication?
A times 1.
1, right? So for addition, you add 0 to anything, you still get the same thing out. With multiplication, you just multiply by 1. That's its identity. Cool?
Cool.
Easy. So far, easy, right?
So far, yeah.
Yeah.
I have a question though.
Yeah.
Say it's like number 2.
Are you looking at problems? Because I'm not looking at problems right now.
Well, it's
I'm going to get to the problems. I'm not looking at problems right now. We'll name the properties in a minute. I promise. I just want to look at what they are first and what they mean. So identity means you add 0 or you multiply by 1. Inverse, additive inverse, is just the opposite, right? You add the opposite.
Yeah.
So
So it becomes
what's the additive inverse of 2?
negative.
You add -2 and you get 0, right? Multiplicative inverse, instead of looking for 0, you're looking for 1. Yes. So that's the idea. So the multiplicative inverse of 2 is a half, and that equals 1. That's what we're looking for. That's our goal in terms of additive and multiplicative inverses. All right? Closure means you get a real number out. You do the math, you get a real number out. You add 2 numbers, or you multiply 2 numbers, and you get a real number. That's the closure property. Cool?
So can it be multiple properties?
Sure. Possible. And the distributive property. You've seen it a million times, right? Yeah, we've used the distributive property a million times. 5 times the quantity 4 minus 1 is the same as 5 times 4 minus 5 times 1. Oh, they like addition. Addition's boring. That's what it says on the paper, right?
No.
What does it say on the paper?
For what?
Distributive property.
Oh.
They use A's and B's, or
Okay.
B's and C's,
A,
Yeah.
yeah.
but it's the same thing, right?
Oh, yeah.
I like to use real numbers in your, so that you can relate it instead of just A's and B's and C's. Gets confusing after a while. Okay. Cool. So, you know these things now, right? If we went through one of these, or two of these, right? You could tell me what property you used. And this is what Hadaway was asking about. Right? So let's do number one. 8 times the quantity 3A minus B. Oh, here are our variables. And we're going to add to it 4 times the quantity 2B minus A. What do I do first to simplify?
Distribute.
Distribute! So, do I have to write it out? Do you need me to write it out, or can we just do it? You guys are okay if I just do it, right?
Yeah.
Sianik, you're good. Nobles, you're good. Babayev, you're good. Vasquez. What do I get? Vasquez, what do I get when I multiply 8 times 3A? Right? Okay. Now we're going to add to it. Nobles, what do I get if I multiply 4 times 2B? Four A, right? Minus 4A. Can I just leave the subtraction symbol there? Cool. Hey, look at that. I have an additive inverse here, right? What's minus 8B plus 8B?
What?
These two things, aren't these opposites?
Yeah,
It'd be 0B, right?
It's the
Well, we don't write it.
Yeah.
Nope, 0, nothing. They go away. What's 0 times anything? Right, negative 8 plus positive 8 is 0,
So
right?
the answer's
Yeah.
just 20A.
It is just 20A. So this is inverse. Right? We use the inverse property to get rid of it. We use the distributive property here on both of those. And then combining like terms, we were good, right? Okay. So Hadaway, we're finally here. Are you mad?
No.
Okay. Now, what's your question about this problem?
No, there's no, I figured it out.
What did you figure out?
It's
See,
just combining them.
it is. That's all we're doing is simplifying. What do you end up with?
51R plus 13C.
What'd you say, 13?
13C.
Does everybody agree with that?
Yeah.
Is that easy enough?
Yeah.
Is there anything difficult here?
No. Probably the easiest one.
Yeah. You'll hate 12. 'cause
The
it's
hardest
got a
one
fraction.
probably number
14.
Sir, 12 is easy, sir.
Say 14.
Yeah, 14, sorry.
Liar. You don't know. Just kidding. Don't forget. Dividing each of these pieces in here by 6 and then multiplying makes it easier,
It's very easy.
right? What's 12 divided by 6?
10D.
2. What's 2 times 5?
10.
See how easy that is? So if they're related, make your life easy. Does that make sense?
Yeah.
Cool? Do you want to work on this? This is it. This is the be all and end all. This is the entire lesson. We have lots of time left, I think.
So I think we just chillax.
Where
I think
am
Bob
I?
I have some homework to do.
Tuesday? Oh, shoot, we don't have a lot of time left. I'm gonna hand out your homework, so you don't have to work on those, too much work. And then I'll tell you what to do for homework. Your homework, because this page is long. See how long it is? Don't do them all.
Too long.
Don't do them all. No, it's this. Do the odds, do the odd numbers, write it on the paper. Odd numbers, and don't do 31. Odd numbers, don't do 31.
Sir, I'm not gonna be here, so
Odd numbers,
tomorrow's-
don't do 31.
I'm not gonna be here Thursday and Friday.
You will miss the quiz. I have to move the quiz, right, because we had a day off?
Yes.
I may make it a quiz instead of a chapter test, a mid-chapter test. Good? So, practice page